Hello students, welcome to Akshar IIT Foundation classes. This is Gafar sir, your physics faculty. Let's start our session. Our topic is what? System of units. Sir. Let me talk about first unit. So unit. So what is this unit? Unit means it is a standard value. Standard value. It is what? A standard value. System of unit means what? It is a standard value. So what is this standard value? For physical quantities, of any physical quantity having a particular standard value, that is called, we will take as a unit. Got it? And next example I am giving. The example is, for example, length. Length is a physical quantity, isn't it? Length is a physical quantity. For this length, what is the unit? Meter. Meter is a unit. Here, meter is a standard value. So next, let us take one more. Force. Force is a physical quantity. Okay, force is a physical quantity. For the force, the unit is Newton. Newton is a unit. This is also standard value. This is the way many in our daily life we deal with many physical quantities. So for all physical quantities having standard value, isn't it? All physical quantities having standard value, that is known as a what? Unit. I hope you have understood what is meant by unit. Now, but here this unit having different system. This unit having different system. Let me discuss different system of units. So now let us discuss different system of units. So very first system is we have three types of system. Very first system is FPS system. What is that? FPS system. Second one is CGS system. Third one is MKS system. MKS system. First one is what? FPS, CGS, MKS. These are the units, system of units. In the system of units, so in every system of units, we have units per physical quantities as look at here. Here in this FPS system, we have foot. F stands for foot, and P stands for pound, and S stands for second. S stands for second. What is this? Foot, pound, second. Here in FPS system, the length, it is a physical quantity, isn't it? Length is a physical quantity. For the length, the unit we will consider as foot is a unit. In which system foot is a unit for the length? In FPS system. And coming to the pound, pound is a mass unit, which means in FPS system, the mass units are pound. The mass unit is what? Pound. Coming to the second is a time unit for in FPS system. Got it? So understand, this is actually this foot, pound, second. Foot is for length, pound is for mass, and time, second is for time. So this is the way we will calculate the physical quantities with these units. Okay. Now coming to the CGS unit. CGS unit. So now when you talk about CGS unit, C stands for centimeter, and G stands for gram. G stands for what? Gram. T stands, other one is second. Other one is what? Second. Here, which means that in CGS system, the length units are centimeter. In gram, the mass units are gram, and time units are second. Understand? So this is about CGS system. And coming to the MKS, M stands for meter, K stands for kilogram. K stands for what? Kilogram. S stands for second. Second is a C. Now in MK system, length units are meter, mass units are kilogram, time units are second. Time units are second. This is how the system of units we have different physical quantities. But here in all it is okay. It is okay with this system of units. But what is the thing here? What is the conflict here? The conflict is the foot cannot equal to centimeter, the centimeter cannot equal to meter. So means we have different system of units, but in the different system of units, the measurement of the length in a FPS system is foot, measurement of length in CGS system is centimeter, measurement of same length in MK system is meter. But these foot, centimeter, meter, all are units for the length only. But the foot cannot equal to centimeter, centimeter cannot equal to meter. That is the conflict here. In all system, the length value, the standard value is not same. It is different standard value. For the same physical quantity, we have different standard value, which means we have different units. But the foot cannot equal centimeter, centimeter cannot equal to meter, meter cannot equal to foot, meter cannot equal to centimeter. So that is the conflict we have. The similar way, the pound cannot equal to gram, gram cannot equal to kilogram. There is a difference we have. Similar way, second, only one thing here, in all system of units, time has same unit. Time has same unit. In CGS system, SI system, CGS, FPS, MK system, in all system, the time has same quantity, that is same unit, that is second. Only the one thing we know. But the thing is, when actually this FPS system generally the Britain people will use. Britain people will use mostly this FPS system. CGS system, Asian countries will use this CGS system. And in MK system, American countries will use this system, this CGS MK system. But different countries are using different system of units. For example, if you want to measure the length, Britain people will use measure the length. For example, I want to purchase a 1 meter cloth. In Britain, the 1 meter, if say 1 means that he will understand as 1 foot. The same way in Asian countries, if you say 1 means he treat as 1 centimeter. In American people, 1 meter means 1 meter. He think as 1 means he think as 1 meter. So there is a difficulty we have. So there is a loss, or there is a loss, or there is a something else happened for while measuring this length. So that there is a conflict we have between the units, such that all countries people gathered, means all the people gathered and having a one system of unit, that is known SI system. That is known what? SI system. What is mean by SI? This SI means System International. What is mean by System International? Why we are using this System International? We have different system of units, but when you are measuring with this different system of units, we cannot have the same physical quantity, same quantity every time. Different countries, when you use different system of units, different units for the same physical quantity, you cannot get the exact thing, so that all people gathered, all countries gathered, have a a single system of unit, that is called system international. So nowadays we are using system international or SI system units for all physical quantities. So according to this SI system, let us talk some important physical quantity units. The some important physical quantities are nothing but fundamental physical quantities. Let us talk about that fundamental physical quantity SI units. Understand? So now I will write fundamental physical quantity SI units. I am taking here. So SI units for what? SI unit for fundamental physical quantities. Fundamental, it is not mental, it is fundamental. Fundamental physical quantities. Fundamental physical quantities. First one is, so you know fundamental physical quantities, we have totally 7 fundamental physical quantities. So the very first one is mass. For mass, the SI unit is kg, kilogram, shortly kg, kilogram shortly kg. This is a mass. Second physical quantity, length. Second physical quantity, length. Length unit is meter. So simply we represent with m. And next, third one is mass, length, time. The time units are in SI system second. Simply we show with S. We show with what? S. And fourth one is mass, length, time, temperature. You can take temperature. The temperature in SI system is Kelvin. The temperature in SI system is Kelvin. Simply represent with K. And fifth one is mass, length, time, temperature. Next one is electric current. Also known as current. The current units is ampere. Ampere is a current unit. Shortly we will represent as A. Ampere is a current unit. And next, sixth one is amount of substance. The amount of substance units are mole. Mole is a amount of substance units. Simply we represent with MOL. Not amol, it is not amol, it is a mole. Not amol, it is mole. Mole is a unit for what? Amount of substance. Seventh one is temperature completed. Next, light, intensity of light, luminous intensity. Luminous intensity also, it is a fundamental quantity. Units are candela. Unit is what? Candela. Not Mandela, it is a candela. It is a candela. Candela represented with CD. Understand? It is not Mandela, it is a candela. Candela unit for what? Luminous intensity represented with what? CD. It is amount of substance. Unit is what? Mole. It is not amol, it is mole. Next, electric current units are what? Ampere. Units is A. The symbol is A. So this is what? SI unit for fundamental physical quantities. Here this is fundamental. Mental, it is not mental physical quantities. These are fundamental quantities. So this is about seven quantities. What quantities these are? Fundamental quantities and its units. So these all are SI units we are talking. Why the importance? What is the necessity of the SI system here? All countries are using different quantities. So we are not having the same thing every time. Since all the country people gathered and kept a round table meeting and finally concluded that all are adjusted to use only one unit here, SI unit. So that way we have the SI units, and that way we have the importance of the SI units. Okay. So children, you got it what it is. Next, so now let's do something. I hope everybody having this book, isn't it? When you're having this book, please open it. Please open it and look at here, the units here. The units here. Just now I discussed the units. Only I discussed that fundamental physical quantity units. So let's discuss some other example for the different units. Let's discuss some example for derived physical quantity units. Derived physical quantities. Give me examples for derived physical quantities. In your book, we have derived physical quantities. Yes, derived physical quantities. Derived physical. I will give some examples for derived physical quantity. First one is area. Second one is volume. Third one is density. And fourth one is velocity. So now, what is the SI unit of this area? Area is nothing but, area formula is length into breadth. Length into breadth. Here length is a what kind of quantity here? Fundamental quantity, units are meter. Breadth is also nothing but length only, isn't it? So that is also having meter. So finally, what is the unit here? Meter square is a SI unit of what? Area. Coming to the volume. Volume nothing but length into breadth into height. Length is length only, distance. Next, breadth also units is meter only, and even height you will measure in what? Meters only. Totally meter cube is a SI unit. Now density formula, mass per unit volume actually. Density means what? Density means what? Mass per unit volume. Now mass units, SI system mass units kg. And volume units just now we derived as meter cube. So finally, the density units in SI kg per meter cube. Similar way, velocity, if you see the formula for velocity, distance by time. Formula for velocity is what? Distance by time. Then distance units are meter, time units are second. So meter per second is a SI system of what? Velocity. Let us give force or else acceleration. Acceleration nothing but length per distance by time square. Distance by time square are velocity per unit time. Acceleration means what? Velocity per unit time. Velocity units already meter per second. Time units are again second. Finally, meter per second square is a acceleration units. And give me any examples here. You can give any examples. Let's see in your book the examples. So they given pressure they given pressure is nothing but force per area. Actually pressure formula is what? Force per area. I did not say force kada. Let us discuss first force. Force nothing but mass into acceleration. Force formula generally what? Mass into acceleration. Then mass units are kg and acceleration units are meter per second square. So finally kg meter per second square. This kg meter per second square also known as Newton. This kg meter per second square also known as what? Newton. Since this Newton is a unit for what? Unit for what? Force. SI unit. So here name, why we are giving the name as a unit? To honor scientists, we are giving name as a unit for the physical quantities to honor the scientists. So not only Newton, different names also we are using as a units, nothing but watt, power units are watt, next energy units are joule. So this is the way we have name as a unit. Okay. So next let me take about pressure. Pressure is nothing but force per unit area. When you are talking about force units, Newton, just now we discussed area units are meter square. Since Newton per meter square is a SI unit for what? Pressure. This also called, this Newton per meter square also called Pascal. Pascal is a scientist name. This is where we have name also as a unit. And next one more thing is also there, momentum. For you momentum also there. Momentum. So when you are talking about momentum nothing but mass into velocity. Momentum nothing but what? Mass into velocity formula it is. So mass is equal to kg. Velocity units are meter per second. So kg meter per second is a momentum units. So here thing is you can, just no need worry about the formulas. Just you have worry about the units. How I am writing the units. Just concentrate on that part. Don't worry about the formulas. Don't worry about the formulas. One by one you will get formulas, but only here the concentration is only on the units, how I am writing the units, where you are taking the, where you are having the what name as a unit, how I am writing the units, focus on that part. Don't worry about formulas. You will get one by one. I hope it is clear how I am writing the units for any physical quantity. If you know the formula clearly, it is easy to write the units clearly. First learn how I am applying the units, how I am applying the fundamental quantities to write the derived physical quantities. See here, look at once concentrate how I am writing. Area you know length into width. Here length units are meter, even width units also meter. Simply meter become meter square. That is how I use the fundamental quantities. Coming to the volume is nothing but length into breadth into height. Length units are meter, even breadth units also meter, even height units also meter. So combined it's become meter cube. That is how I applied fundamental units to write derived units. And coming to the density. Density formula is mass per unit volume. Density formula what? Mass per unit volume. Here mass, let us write here capital M to get confused. I am writing here capital M, this is small m's. Here mass units are kg, that is fundamental unit, and volume just now we derived meter cube. So kg per meter cube is density units. Similar way, velocity formula, distance per unit time or displacement per unit time. Displacement units are meter and here time units are second. So finally meter per second is a SI unit of what? Velocity. And coming to the acceleration, velocity is for acceleration is acceleration formula is velocity per unit time. Velocity units already earlier we discussed that meter per second, that is what I written here per unit time. So finally it is become meter per second square. So that is how applied fundamental units to write derived units. And one more type of units also we have. The one more type of units is supplementary quantities. Supplementary quantities we have. The supplementary quantities units, if I discuss, that is close our the chapter, the synopsis. So supplementary units. So what is that? Yeah, supplementary. Supplementary physical quantities. What is a supplementary physical quantities? The supplementary physical quantities, we have two supplementary physical quantities. One is plane angle and next one is solid angle. Solid angle, simply solid angle. Here plane angle units, SI unit of plane angle. SI unit of plane angle is radian. So simply we will call as rad, not rod. It is rad, not rod. Okay, not sticks and rods. This is radian. We represent with rad. So generally we will calculate the angles. Actually here plane angle nothing but simply angle. Angle we will measure in degrees. The degrees is not SI system now. This is CG. Actually that is a CGS system. CGS system for angles. SI system is what? Radian. And coming to the solid angle. Solid angle is what? Steradian. Steradian is a unit for solid angles, simply ST. So this is about what? System of units. Now look at the one's practice sheets. So look at the practice sheet, everyone. So in the practice sheet we have questions like among the following. First question, look at here, conceptual basic questions. Among the following, the derived unit is. So here, once you know the fundamental units, easily you can identify what are the derived units, because only fundamental quantity units, only fundamental units. Derived quantity units we will call as derived units. Got my point? But how many fundamental quantities you have? 7 fundamental quantities you have. How many are there? Totally 7 fundamental quantities. In that 7 fundamental quantities, just 7 only there, not much. No more, we have only 7 fundamental quantities. See the options here: Ampere, Candela, Newton, Kelvin. 4 options they given. In the 4 options, only third option is our answer, because they are asking derived unit. Remaining 3 all are what kind of quantities? Fundamental quantities. Next, SI unit of luminous intensity. So SI unit of luminous intensity, just now I discussed that here, candela. The remaining options are not. SI unit of plane angle. So SI unit of plane angle, just now I discussed here, radian. SI unit of force. See here, to talk about SI unit of force, there is a different forms they given. N, small n, Newton, and in small Newton. This is the way they given. But how do you know what is the correct option? To know the correct option, we have some rules and regulations to show the units. The rules are, first rule is, so the simple rule, the rules for writing the names, rules for writing the different things. So here rules for writing the SI unit. So first rule, rules here, rules for SI unit. So here, for example, discuss shortly here, I will take not much time. So first, when you are writing name as a unit, for example, we have a Newton. Newton is for unit for what? Force. So when you are writing name as a unit, when you are writing total name as a unit, just write down Newton. So must be start with a small letter. When you are talking about Newton whole name, you want to write whole name as a unit. Just start with a small letter. For example, if you write same unit as a symbol, you must show here in this case you should not start with capital number. You should not start with caps. When you want to write total name as a unit, you start with small m. If you start with capital N, it's incorrect. And similar way, same thing you want to show in a symbol, you have to show symbol as capital N. Symbol as start with capital N. You should not show symbol with a small n. Okay, that is how the rules for writing name as a unit. And coming to the, every time when you are writing about unit, you should not give plural form. For example, meter is a unit. So for example, 3 meter is a length we have. You are supposed to write only 3 meter. You cannot write 3 meters. This is incorrect. You cannot give a plural form for the SI system. Only you should give singular form. So 3 meter is this is the way you must write the units. I hope you have understood what I explained, and so understand. And even different already I given SI system symbols, SI system units symbols. You must use that symbols only. You cannot use other symbols. For example, Kelvin, for example, kg we have, right? Mass units are what? Kg. So kilogram units, kilogram is a unit. When you are talking about kilogram is a unit, you should use kg only, not any other thing. If you want to write meter, you should use small m only, you should not use capital M. So these are the rules we have to use to write the physical quantities. I hope you have understood. By using that, can you tell me the SI unit of force is, the SI unit of force is, you will get 194 options are correct. That way we can write. Similar way, SI unit of volume is 4th option meter cube. So this is the way you can try your problems from your worksheet. So I hope you got clarity for today. So I'll stop the session. Until then, bye bye.